Osas, thanks a lot. Welcome to the show. Thanks for coming on the show.
Hey Pete, it's my pleasure. Thanks for having me today.
Yeah, welcome. I've been hoping to get you on the show for a while because we've been looking at your startup for many months, maybe 6 to 9 months, and it's pretty exciting because it's in one of the core areas, isn't it, of climate change. So if this podcast is all about looking at founders and companies that can help address climate change, then you're looking at one of the biggies, which is steel. So I thought maybe a good place to start is talking about how is it that steel is contributing to climate change at the moment, and why is it that I say, and am I true when I say that it's one of the big ones?
You're definitely right. So there are a few biggies out there, and on when it comes to materials, steels as well as concrete are like they're at the top level really. If you think about it on a larger scale, you've got transport in there as well. But the contribution of steel alone accounts for just under 10% of all global emissions. So it's an incredibly huge contributor to climate change and also global warming. There are lots of conversations within the steel industry, outside of the industry, when it comes to policymakers, the in terms of the larger economy, and everyone's talking about how can we solve this problem. So it's an incredibly exciting one that we at Deep Meta can have the privilege of actually working on at such an auspicious time in history. So no, it's a very exciting space to be in.
What is it? What is it about steel that is producing all of these emissions? And is it CO2? Is it methane? Is it some kind of fluorine? What is it producing,
Yeah,
and how is it producing it?
very good point. As you know, and I'm sure quite a lot of your listeners on this podcast would also be aware of that. Depending on the kind of greenhouse gas, it will have a different kind of level of effectiveness when it comes to how much of the greenhouse gas effect can it actually create. Of course, you've got your fluorines up there, which are very influential. You've got things like methane, which obviously is very bad. But when it comes to like volume, CO2 is the largest contributor by volume in terms of the greenhouse gases. Although, and so as a result, it's used as a standard for how we then determine the impact of other kinds of gases as well. So with steel, it's actually CO2. It's none of the others. It's primarily CO2, and the reason why it's CO2 for steel is actually because of two factors. One is the amount of energy it takes to make steel, and two, it's because of the method for making steel in the first place. So, if you don't mind, we might go to some 101 chemistry.
Sounds good. Yeah.
um, so in most instances, when you want to make steel, right, you can make steel either from iron ore or you can make it directly from scrap metal. And depending on what route you take, you have like a different kind of processing route. The largest plants in the world, they make it through what is called the blast furnace route, and so they start off with iron ore. So iron ore is iron just in the wild in nature. It's just literally iron oxide. So typically Fe2O3, and the aim of the game is to actually take away the oxygen and just be left with iron. And so that separation process is called reduction. And you can reduce iron in various you can reduce iron oxide,
So quick,
and
quick,
then
quick question on that then. So you've got this. It's a mix of iron and oxygen, and you want to pull the oxygen away from the iron to leave you just with iron in the iron
yeah,
element,
exactly.
and so you're using carbon monoxide, which you get from somewhere, who knows where, in order to pull that oxygen to make to go from CO to CO2. Um, is that in essence what you're doing?
That's exactly what it is.
So
And
does it have to be carbon monoxide then? Could you not use something else to pull the because
yeah,
it's the
you
carbon
totally
which is the
can.
problem here.
Yeah, so you totally can, and like there's lots of work that's going into using alternatives like hydrogen, and in order to help to reduce the iron oxide into iron. The challenge with that process, there's lots of promise there, and in the future we're likely going to move in that direction. But in terms of where steel companies are right now, it's difficult to make that transition for a few different reasons. One reason is the capex. They're going to have to change their entire plants, and the steel industry is one of those spaces where it's a high volume and a low margin industry. So they they tend to limit how much reinvestment there is because there just isn't that much at the top. Um, and subsequently, like there's just like a lot of there's a lot of slow progress towards making that transition for these steel companies because of that capex. The other thing is, in the event that they can change to hydrogen, um, it's going to cost a lot more energy to actually make steel. So at the moment, the reaction that in a blast furnace makes lots of off gases, and these off gases can, in some cases, account for like they can be used to then make energy in these plants. And these can account for like 60% of their energy production. So you've got these steel plants, which are basically power stations, making more than half of their own energy, right? Which greatly reduces their energy consumption and what they're pulling from the grid. Um, so let's say, in 50 years' time or whatever, we have a great scenario where all steel is being made through hydrogen reduction. Um, Even though the steel itself might have a lot much lower carbon impact associated with it, what we haven't solved, if we don't solve it by then, is decarbonizing the grid. Because then they're going to need to have a lot more external energy to be able to make the steel now. Because instead of going via the blast furnace route, it's going to be a different route called the electric arc furnace. And that's where you basically use these high-powered carbon electrodes to melt down the iron into molten into molten steel. You can alloy it, etc. And that route is available now, but the grid is not decarbonized. Um, Typically, the kind of steel that is used there, that is made there, is from scrap. Um, and and so there's a carbon emissions associated with that.
I see. So
But
if I can kind of summarize what it is that you said so far, then, so that the process of creating steel in a blast furnace from iron ore it generates CO2 in a couple of ways. One is like in the use of the energy that it pulls from the grid, but the second way is there's something to do with the chemical reaction in that you're putting in carbon monoxide. You're getting the carbon monoxide to pull an extra oxygen off the F2O3, if I've got that right, and that makes CO2.
yeah,
So the chemical
exactly.
reaction makes CO2.
Yes, exactly right. And so there's two pieces there. There's like a fundamental way that we make steel that needs to change, and two, there's an energy efficiency bit where it's like, okay, how can we become more energy efficient in the way that we're making our steel, so that when we do have hydrogen reduction and we have that becomes ubiquitous in how we make steel, we need to be able to do it with less energy. Otherwise, it's going to be super expensive. And that's where tech like deep meta comes in. It comes in the in it comes in the short run to try and manage the issue with capex, i.e., the capex that's slowing the transition to these new technologies, new ways of making steel, and also in the long run, when energy efficiency becomes very important in this industry. It is already, but it will become more so when all their energy is being pulled from the grid. And in the short run, it has an impact because, like I mentioned, these companies, they don't have that much money to actually invest in new infrastructure. And so we've got to try and find ways to make them more efficient today, to help them to reduce their energy consumption and subsequently their carbon emissions. So how can we do that in a cost-effective way? When we go across that whole production line, the wastage at each incremental stage comes to up to about a quarter of all steel produced in an average plant, say that is making around 3 million tons of steel a year.
Wow. Okay, can we
And
pause there?
so
Because I mean that's a big headline figure, isn't it? 25% on average is waste. So we're making this material which generates loads of CO2 just through the chemical reaction used to create it, and 25% of that is waste. What does that roughly add up to, like globally? Like how much steel is produced
Yeah.
globally?
So on a global scale, we got like 1.8 billion tons that are made every year. Um, One way I like to help people imagine it, even though it's still quite difficult to perceive, is that that's enough steel to build all those skyscrapers in Manhattan, New York, 100,000 times. Um, so like we make a huge ton of this stuff every year. About half of this goes into the construction space, which is not surprising. And so yeah, it's there's a big deficit on CO2, as in when it comes to looking at CO2 impact in the built environment. If you were to have some kind of a if there was to be some kind of accounting system for your assets and liabilities of carbon dioxide, when it comes to the construction industry, they're very much like in the negative because they just have inherited so much carbon dioxide from just making the stuff in the first place before they even get to make their buildings.
So 100,000 times, like 100,000 Manhattans every year. I mean that's insane. So what you're saying is 25,000 Manhattans are being built, like, and then just thrown away through this wastage process. Okay, so as far as I understand, then the purpose of deep meta is to look at all of this wastage, which kind of tots up globally to about 25,000 Manhattans every year, and see what you can do to reduce that. So how are you reducing that wastage?
Yeah, good question, Pete. So at Deep Meta, as I mentioned before, regarding that these plants already have loads of data on their production lines, but many of them are not they're not being optimized, they're not being fully utilized. So what Deep Meta does is that we capture all the data on the production line, and we use machine learning to basically create a classification system of products which are defective and those which are non-defective, and we are then learning the processes and that are associated with a successful event, i.e., a product that was done well, and those which are not done well. And then based upon that, we then make future predictions off of a current run of on the mill, if that's going to be defective or not. If it is going to be defective, what do you need to change in order to avoid that?
This is the bit that I've struggled to understand in the past, because to me, to the untrained layman in the street, steel is steel is steel, and I would have thought that they'd kind of finely tuned their assembly line to produce perfect steel every time. So how is it that that the settings on the assembly line are changing from run to run?
So the assembly line settings always change because you have different kinds of products that are made in this on the steel plant. So, for example, you can have different dimensions. If you're going to be making products like rod, then you might have some that are 17 mil, some that are 10 mil, some that are 5 mil. And depending on what product it is, you're going to be changing the different dimensions on the mill. But when you go between, say, 5 and 17 and then 12 and back to 5 again, it's never going to be exactly the same. So that's just one example of something that on the line that is dynamic and difficult to replicate. And so it's difficult for the operators to be able to actually identify what will be the most optimum position for that product. Second thing is that there are differences in the actual composition of the steel, and different compositions of steel behave in in dissimilar ways. What I mean is you've got some steels that are a bit harder, some that are a bit softer, and so the way that they're going to be interacting with the machinery, it differs. Machinery itself changes over time, so you've got some rolls that can become harder. That's due to something called work hardening. just because they are pressing the steel together to make it form into a certain kind of shape that will be ideal. It also affects the tooling, and so it's a dynamic process that you can't just have a fixed setting for it and it will work every single time. There are these nuances that need to be taken into consideration when you are thinking about what's going to be the most optimum setup for me at this point in time. And because of that change, and that's what makes things like deep meta useful, because what it does, it basically learns from historic knowledge. And people on the production line, they're incredibly knowledgeable, highly skilled, and we're going to be capitalizing on the data that they've collected so far and their expertise to be able to inform their future decisions.
Yeah, nice, nice. I've seen similar things happen in kind of medicine and in law, where you've got a bunch of human experts. Where the kind of I suppose the principle is decisions made by humans but informed by machines. Where you've got an AI that's, or a machine learning model that's looking at all of the available parameters and then making a comment that the humans then look at, and that informs, okay, so there's something we didn't think about, and together they make something which is better than either making the decisions by themselves. Is that something similar to what you're doing?
I think that's a pretty good. It's a good way of explaining it. I think that's a reasonable analogy. And as you say, it's not just in steel production or in medicine, but actually it's likely going to be in increasingly different parts of society and aiding decision making, because we've got so much data out there, and this is kind of the double-edged sword of big data, if you like, in that you've got loads out there, which is great because it's given us new ways to inform our decision making. But human beings were not designed to like crunch huge amounts of data. We are designed to make nuanced decisions based upon things that might be hard to detect by current machines anyway. But handling all that data, it's not what we're made for. And so a marriage between these two kinds of performances is going to be really critical going forward in the future in various industries.
I think another thing that machines are obviously very good at managing lots of data. They're also very good at handling high dimensional data. So we can maybe look at something in 3 dimensions or maybe 4 dimensions, maybe sometimes 5 dimensions, and
Yeah.
it's got color coding and it's got some kind of animation going on in it. But machines are able to look at things with millions of parameters, or sometimes even billions of parameters, and spot patterns that we're not able to spot.
Yeah, exactly. And I think that's what makes it makes it quite interesting and compelling, especially when it comes to the steel industry. There are so many variables to consider. So just to give you an example, like for one process, so I think before I talked about these 4 stages in production, right? And just in one stage of these production, we've got for a customer just for like one day about 5,000 variables, right? And so for a human being to then consider like the impact of those 5,000 variables, in the next for the next 10 seconds of a production process, you're asking for a lot. But for a machine, that's what they're made for. And then when you give the operator, somebody who's been skilled, somebody who's been doing this for years, enough information, they can then make an informed decision. Like, okay, this will be the best thing to do right now based upon what I'm being fed. And that's what we're trying to achieve right now.
I think this is one of the things that's amazing about your company, is that you're not asking people to change the way that they work. You're not asking them to install new machinery. It's mainly software, isn't it? You're using the existing
Yeah.
sensors that they have already, and you've actually, even though you're quite early stage, you've managed to get people to, like, factories to give you their data, and you've been able to make some progress with that, right?
Yeah, it's been a journey. When we first started out, we would basically find someone on LinkedIn. We would message them on LinkedIn. They would then find their email on hunter.io and be like, "Hey, we've just sent you a message on LinkedIn. Have you seen it yet?" But with the cringiest lines, just to try and get their attention. So we did it again and again and again, and some people positively actually responded, and through there we're able to build some pretty cool relationships, and because they could see the potential for this in their mills. They could see how it could change their industry, and also that it's quite frankly it's the future of their industry. And when you look at the steel industry, is a space where 5 6 years ago people were very they were kind of they weren't so open to advanced technologies, but this is changing a lot, and it's changing in the sense that they are looking for solutions, but they're not quite sure where to go to because it's a very new space for them. It's new territory, and the ones who are getting it, it's exciting to engage with them, and so through those. Over time, we've been able to accrue more than 1 year's worth of proprietary production data from these plants, and it's allowed us to be able to get some really strong proof points, which is exciting for us.
Yeah, amazing, amazing. So I'm interested in this kind of cold call approach that you took. When I first started my first startup in Paris in the 90s, we used to like just go from door to door. Like we went into all the shops saying, "Hey, do you want an e-commerce website?" And they were like, "What's a website?" Because we were ahead of our time, and we had no idea like how to segment customers or anything like that. We literally just went into an estate
Yeah.
agent, and then next door there's a beauty parlor, and there's a nail bar, and we went everywhere. How did you decide like who to reach out to?
Yeah, so we knew that the people who care the most are the integrated steel mills. So integrated steel mills are the people that kind of what I was describing before make steel from the ore or from scrap iron all the way to a finished product. And that's because they deal with the largest volumes of steel, and subsequently they have the most to lose and the most to gain, should they change something in their production. Other smaller kinds of players in the steel production, in the steel industry, such as secondary steel mills, they tend to buy in semi-finished steel and then they roll it. So they only kind of take one part of the process, and they tend to make all the same products. Not There's not so much diversification, which introduces less complexity into their production line. So we just saw that they didn't care as much. So we focused really on integrated steel mills, and we then decided to try and find people in those steel mills that were working on the production line because they are the ones who felt the pain and they are the ones who would be our users. So we focus on contacting melt shop supervisors, managers on managers who are on the rolling mill. And if you can get in contact with a plant manager, like or the mill manager, that's great because these these mills they basically have their own budgets, and so the mill manager is the person who holds the purse strings, and then they can decide, whether or not they want to pay for something, etc. And so they might not be the direct user, but they are the purse string holder. And so understanding who to contact when and how to build that network, was has been an interesting journey for us.
The A lot of being an entrepreneur is finding finding the product, finding the pain point that people will pay to have fixed, isn't it? And then you've got to go and test, will people actually pay to have this fixed? How did you come up with this thesis in the first place that these were the people in these plants that had this pain point?
Yeah, so I suppose that started off with my from my PhD times. So when I did my PhD, I was sponsored by industry, one of the largest steel producers in the world. So I was very fortunate to be able to get some exposure to their production lines, and also to the people that worked in research for them. Uh, as a result of that, I got an idea about who was who on the production line and what mattered to different characters. So that gave me my starting picture of, okay, if I were to use this as a template, who's gonna care when I go to this other steel company? And so I can kind of like match these characters that I had been familiar with to these new people, and it seems to match up quite well. Like, and what typically is the case is that you've got two lines that are most that are I guess are most well connected or are most well suited to be working with deep meta, and that's R&D and production. So R&D assist production so that they can solve problems that are otherwise too hard to solve the first time round. Um, and production are the ones who are obviously who are concerned about making high quality products that can be sold to customers. With R&D set up, they're always looking for new ideas. They're always looking for new ways of doing things and wanting to work with people. So that has been like a pretty effective route to engage with new companies, because what they can do is they can organize and package a really cool project that can be a proof point for the company at large, and then get the commercial interest of people in the mill, because they'll understand what's going on at the mill and what's priority and what's really hard to solve that they can't solve now. And so through that, we're able to identify problems that lend themselves very well to deep metastasis, um, and subsequently been able to get some great interactions with people who are on the production line.
So you did. Let's talk about the idea, the genesis of this idea, and then how you brought it to market. So you spent a lot of time in academia, didn't you? Between Cambridge and Imperial, you did a PhD at Imperial. But now you're a founder, and that's not often. I mean, VCs love founders who've also got PhDs, but it's not necessarily a guarantee, is it? Because you've got a PhD that you're going to be a good founder. Um, but you're making big waves, and you've got some really big fans as a founder. So I just wonder, do you think you always had this heart in you of being a founder, or was it that you came up with an idea and thought, hey, this could be a company, or did you always want to be a founder and that you were looking for an idea?
That's interesting. I think that I have always had the heart to start things, to start things and just to like put things together to make stuff happen. And I think that that's kind of how I've been for at least throughout my teenage years, as I can recall now. And some instances of that are just like plays that I'll pull together with people in my community. I'll have an idea. I'll pitch everybody. I'll say, "Look, I think we should do this," and it might be in the most obscure thing, but I'll just try and get like a cast together, and we'll somehow make it work.
Oh,
So I got a
plays.
lot of
You mean theatre?
huh?
Theatre. Is it plays?
Theater plays, yeah,
Oh, I
theater
see.
plays, yeah, yeah, yeah. And so I got a lot of satisfaction out of having a vision and just like getting people to come on board and bringing that to life. And so that's something I just like to do. And then I guess it was probably during university, the idea of having like a business came to my mind, but it's not something that I ever really like pursued actively. It was just it was a nice thing to consider doing sometime in the future. So I went through academia, as you mentioned. I did my undergrad at Imperial. Was did pretty well there. Was very very fortunate to have great people around me, a great support system. Then I went on to Cambridge to do my master's, also in material science. Then I took a gap year actually before then starting my PhD, and I suppose it was during my PhD and the exposure I had to the steel industry that allowed me to begin to think, oh, I actually think that there's something here. There is an opportunity that is almost ripe for the picking, um, and is effectively a low hanging fruit. One where there doesn't seem to be enough people within the industry who have this skill set to be able to effectively do it like internally, and there's going to be demand for this in the near future. And so, as is common with me, I spoke to some of my friends, and I told them, "Hey, look, this is what's going on. I think that this could be really interesting. Would you like to work on this?" And so some of my buddies from Cambridge joined, some from Imperial, and then from there we just other people who didn't know me personally began to also join the team, and so now I think there's five of us now, and then like some who are part time outside of the five, just because they're passionate about the project, and it's just great to get people on board with something where they're building their own careers, they're adding value to their lives, but at the same time, there's a much bigger vision of actually the impact that we're going to be having on the world, especially on an industry that accounts. It's the most widely used metal in the world. It accounts for a huge amount of GDPs in countries all around the world. It's $1 trillion industry, uh, and to think that we can play a role in actually changing the way it's made and the way that people interact with it, it's so exciting.
Yeah, that's a really interesting story with lots of interesting ingredients. I'm always looking for what are the ingredients of great founders, and founders are all different, aren't they? So it's difficult to find a common set. But being a doing a PhD is often kind of the opposite of being a leader of a business, isn't it? Where doing a PhD is going right down into the details and focusing on being a specialist in an area that very few people understand. Whereas being a business leader is about, hey, looking up, getting up off the dance floor, up onto the balcony, and getting a lot of people excited about something. And it sounds like you had those ingredients from your art background. So you play sax. I read on your in your background. So you were in theatre. So you've had kind of artistically some exposure to getting a load of people together, and getting them excited, and forging forward towards a common goal.
Yeah, no, I would agree with you. I think I've been very fortunate to have quite a diverse background, in the sense I've been able to get involved in various kinds of art forms and different forms of expression and different forms of learning, which has meant that I being an expert, as you say, as a PhD in one thing, rather than giving somebody tunnel vision or making them like just be really really good at that one aspect, it actually in it actually presents insight, and that insight is what allows you to notice something that no one else has noticed yet, and as you say, become that person who can be like, wait, hold on, everybody, I just found out something amazing, you have to hear this, and getting everyone on board with it. But I think that you can only be that person if you've learned something, and for me, that was achieved through the PhD.
So when you cast your mind forward to like 2050, so the whole world is trying to get to net zero by 2050. I don't know whether are you optimistic or pessimistic about our chances of being able to do that.
I mean, I think anyone who has a startup is an optimist. So it's a bit of a trick question. I think I am optimistic about us being able to achieve that. I think there's going to be lots of challenges in the way, for humans to be able to get to that length. I think there's going to be needs to be a lot of cooperation, and I think there is. We're going in that direction, but I don't think I don't think we're exactly there yet. Uh, in terms of the steel industry, I think that the steel industry is working increasingly together, especially when it comes to climate change. And I think we have a very good chance in that industry to become net zero by that time. I think out of COP26, a couple of countries, including the UK, uh, basically signed an agreement to make steel that has a lower carbon impact, and has agreed to have basically to make a 2030 target ahead of 2050. In the next in the, by they want to make that target clear by mid 2022. So by mid next year, UK, India, and a few other countries want to declare how they're going to work towards this target. So I think that accountability within the community, within the community of steel producers, I think is going to be very key, towards 2050 being possible. If not for every single industry in the world, I think some are going to be able to achieve it. And if we can do it in the most critical and the most polluting industries, then I think we're on the way to making a big change.
When you look forward to the world that your kids and maybe even your grandkids are going to be living in 2050, have you got any vision in your head about how the world might be different? Some people see that there might be more forests. If you've got any vision about that, what I'm very compelled to see is that people who talk a lot about reducing carbon emissions also talk a lot about improving everything across the SDGs, so improving access to clean water, having better education, better jobs, and that kind of thing. Don't know if is there anything in your mind that stands out as, man, I hope we get to this point by 2050.
Yeah, I mean, so I also teach. So for me, a big part of life is education and having accessibility to that. So by 2050, I want to see a world where, every girl and boy who wants education, or maybe, yeah, every girl and boy who wants education, and every girl and boy should be able to be exposed to the opportunity to be educated and make a decision for themselves based upon that, should get it. And a world where you have many educated people. I mean, human beings we're pretty smart overall, and I think having more smart people on deck to solve big problems is going to be crucial. We can't wait for one part of the world to be feeding the solutions to everyone else, and so I think people making indigenous solutions for their own problems is going to be really important. And so I think I'd love to see more of that. We're going to be able to see a really wide breadth of creativity, which is going to be exciting. And from the standpoint of deep meta, we definitely see a world where by that time, steel plants are far more efficient. We're integrated into every single steel mill. It's where like a non-question just goes without saying. But we want to transition from being a company that detects defects on the production line to be one where we're providing information about the flow of steel throughout the supply chain. And because steel is used so ubiquitously in society, there can be a lot of information that can be derived from its flow in various aspects of the economy, which will be really good information for decision makers in facilitating a truly circular economy. And one example of that is in construction, which I think it's a pretty exciting opportunity for us.
Awesome. Well, I think that's a great place to leave this, and maybe you can come back next year and tell us, how you're getting along with your
Yeah,
plans.
well, it's been my pleasure, Pete. Thank
Yeah,
you.
thanks a lot for coming on the show, Dr. Omoigiade. It's been so great to meet you. And listen,
Thanks for
yeah,
having
stay
me.
in touch.
It's been my pleasure.
Thanks, Osas.
Yes.
Cheers. See you around.
All right. Cheers, Pete. Bye bye.